Hello, I'm Hunter, and I'm a freshman at Vista Ridge High School. I'll be showing you how to properly record data and conduct an experiment. Now, first, you're going to want to choose your experiment. It may already be pre-chosen for you, but for this example, I'm going to measure with this ruler, always on the metric side, because you don't want to use the inches side. Anything customary, you usually don't want to use in science. I'm going to use this metric side of this ruler to measure how far away I can light this light bulb from this Tesla coil. Now, I have my power supply set up, and I'm going to safely, with insulated equipment, plug this in. I'll first demonstrate that it does indeed work, and it does. Now I'll choose a fixed point on this light bulb. For here, I'll use this mercury symbol right here as Hg. I'll use that as a fixed point to measure from. And then I'll always measure from the center of this sphere. Now to do this, I'm going to place the ruler right here. I'm going to line up my mercury symbol. I'm going to slowly move it forwards until it begins to glow. Right there, 26.5 centimeters. I'll then continue to take my utensil, a pencil that's sharpened, a pencil, let's say, a pen or a pencil, and I'll mark it down on any piece of paper will do. For this example, I'll just use this scrap sheet. And you're going to want to make a table for something like this. What I'll do is, I'll mark down, I'll make a T-chart, just to keep it simple. I'll mark down the voltage, so V for voltage, and then the range, which I will mark in centimeters. My current voltage is 32, and the range was 26.5 centimeters. Now, as I adjust the voltage, which is called the independent variable, because I change. Because I change it, it's called the independent variable, and I'm not measuring this. I'm changing it to affect what I'm measuring, and I'm measuring the range. So now we're at 28 volts. That's a difference of 4 volts. So we're going to mark that down on our table. I'm going to plug this back in safely. And now we're going to set up our ruler in the exact same fashion we did before. I'm going to line up my light bulb, and I'm going to begin moving again. Oh, let's try that again. Didn't quite get it. $23.5. Mark that down. And we'll repeat this process until we have a significant amount of data. And this varies on your experiment. Usually with human experiments, you may only need 10 subjects for something like for the science fair. For this, you may want to run this at maybe, let's say, 6 different voltages, but you're going to want more than one trial. And a trial is basically a set of data. So every time I do another 6 volts, I'll do the same voltages, and I'll measure it again in the same environment as before. That way it's as controlled as possible, and very little is changing. That way the trials can be as consistent as possible to make more accurate data. An example here of something that's completed with data measurement is my science fair board. This shows right here that I do have my voltage and my range in centimeters as before, but I have different voltages for this. For my project I use 18 down to 9 in 1.5 volt increments. I then measured the range, and I have 3 trials. That way I can get as accurate data as possible. I then averaged them together and found something called error bars, which you will learn about in 9th grade. I then created this bar graph. Usually you're going to use bar or line graphs for experiments. I used a bar graph to show the average in all of the different voltages, and then the error bars to show standard deviation, which, 9th grade. Well, this was how to record data, and see you in the next one.